Okay, so today we're going to be talking about section 1.4, which is other effective methods of sampling. So, as we kind of said last time, randomness is important, but if you wanted to do a simple random sample, you do need to get that frame, which might be a little costly. So, let's think about the whole goal of sampling to begin with anyway. The goal of sampling is to obtain as much information as possible about the population at the least cost. By the way, cost could be referring to time, money, or other resources. Now, why would we sample in the first place if we could just ask everybody in the population, right? I mean, typically, if you could, you would just ask everybody their opinions. Well, it's too expensive. Okay, that's why we go to sampling in the first place. Well, turns out getting a simple random sample means getting a list of everybody in the population. That could be expensive too. So maybe there are other ways that help guarantee more information for even less cost potentially. Let's dive in to see what other types of sampling there are. First type of sampling that we'll encounter other than random sampling or simple random sampling will be stratified sampling. So I'll read the definitions and then we'll get going with more of an intuitive look at it. A stratified sample is obtained by separating the population into non-overlapping groups called strata, then obtaining a simple random sample from each stratum, and then that's how you get your overall sample. Now, importantly with stratified sampling, we're going to require that the individuals in each strata are homogeneous, meaning the same, in some way. Now, I know I'm getting kind of wordy here. Let me throw in a little bit of an example to help us picture what this actually is. Say that you want to know who's going to be voted in as president in an election year. Well, you could get a simple random sample, just ask random people. But maybe you think you're a little bit more clever. You say, well, in America, I know there are roughly, say, 26% Democrat, 24% Republican, and the rest, 50%, are independent. Maybe if I want a sample size of 100, I pick 26 Democrats, 24 Republicans, and 50 independents, and see what they have to say. Well, you just did a stratified sample. In that case, what you did is you broke down the population by some kind of way in which each group is the same, Republican, Democrat, Independent. You pick the sample from each of those groups, and then you got your sample and got your information. Now, importantly, in that example I just did, the strata weren't of equal sizes. The Republicans were 24%, Democrats 26%, and Independents 50%, vastly outnumbering both other parties. Well, that's not a problem. It just needs to be proportional to the size of the strata in the population. So don't be going and picking 99 Republicans, 1 Democrat, or vice versa. Now, why would this be of advantage? Well, it can allow for fewer individuals to be surveyed overall because you're getting that information already up front that, hey, I'm representing all political parties in that case. And something that's kind of nice is the researcher can determine strata characteristics. For instance, maybe I want to do something on taxes. Let's say that I want to study whether or not people think that the tax laws in America are sufficient. Maybe what I do to do a stratified sample is I break down the overall American population into their tax brackets. You know, the highest, middle, second middle, lowest, and so on and so forth. Well, one thing that by doing a stratified sample I can see is whether or not different groups agree differently. Maybe the top 0.01% say, hey, yeah, don't change that tax code at all, versus the bottom group would say, yes, tax code needs to be revamped. Just like the presidential campaign where maybe during, say, Republicans' reign as president, Democrats might have a higher disapproval rate than, say, Republicans would. Stratified sampling allows you the ability to observe those different groups and see what's going on. As an example, here are different strata that you might do. If you're studying, say, college students, you could break down the college population into freshmen, sophomores, juniors, and seniors. If you're studying America, you could group states together. If you're studying, say, any population, you might want to group ages together. You could do, like I said, Democrat versus Republican versus Independent. And you could also do times of day. Maybe you're a restaurant owner and want to see whether people spend the most money in the morning, in the afternoon, or in the evening. So long as how you're breaking down the population, so long as those groups all share something in common, like this group is all in common, this group is in common, and this group is in common, this is going to be stratified sampling. Now, maybe you don't want to think too much and you just want to do something a computer can program for you. Well, if you're doing something that, say, anybody can do, like my 5-year-old nephew, you would be doing systematic sampling. Now, let me dive further. My 5-year-old nephew could do quite a bit of stuff, but systematic sampling, I'm telling you, anybody can do. A systematic sample is obtained by selecting every kth individual in the population. Maybe you're a manufacturer at a plant and you're doing quality control. How about you just select every 10,000th item to be surveyed and to be inspected? That would be systematic sampling. You're just picking every 10,000th individual. Now, the nice thing about this type of sampling, no frame required. You don't need to know really anything about the population. You can just start picking. Say, yep, I'm doing 7,000 of them. Every 7,000th, for instance. Well, what would be nice about that? It can provide more information for a given cost than a simple random sample. It's super cheap to do. And by the way, since it's easy to employ and just about anybody can do it, turns out there's less of a likelihood for errors. Something that we'll talk about later will be when you can kind of see errors in sampling. Well, when you're doing systematic, just make sure you're counting right. You'll be on track. Now, if you wanted to get into the mathematics as to how to make this efficient, what you should do is the following process. First, try to get your hands on the population size, capital N. That way you kind of know how much you're dealing with to begin with in your whole study and as far as population size goes. Second, determine your sample size desired, lowercase n. You might need to have that sample size be at least a certain amount because you want to ensure quality, but you don't want to go too high because then all of a sudden it gets more expensive and kind of holds up the process. So getting your sample size is required. Next, once you've got your population and sample size, what you're going to do is divide the two numbers. Take population size divided by sample size. Once you do that, round down if you have any decimals and call that value K. So, notice K popped up right here. That's going to be how many things you pick. So, for instance, we talked about every 10,000th person or every 7,000th. That was what K is, 7,000 or 10,000. Now, just to ensure a little bit of randomness, what you could do is make sure that you're not having the first be your starting point. For instance, don't start off with the first product of the day. Maybe start off with a random product and then pick up your sampling from there. So, hey, pick a random number in your first, say, 7,000 different things. And then all you do is you just start going. Now, I'll go back to this. I kind of want to show you an example. It makes sometimes me doing stuff like this is way more confusing than actually seeing it. So, let's see it. Human Resources at a certain company wants to conduct a survey regarding worker benefits. The department has an alphabetical list of all 3,288 employees at the company and wants to conduct a systematic sample of size 40. Hey, notice this. We just kind of gave you lowercase n, sample size is 40, and capital N, population size 3,288. Now notice it's asking what K is. Well, remember, in order to get K, we already got 1 and 2 done. Hey, that's kind of nice. First, we need to divide capital N by lowercase n. Now, if we do 3,288 over 40, I expect everybody to do this in their head. No, I'm just kidding. I'm going to pull up my phone too on this. So if I pull up my calculator and do 3,288 divided by 40, I'll get 82.2. So, boom, there's my number. Now, we want K to be an integer. We want it to be a whole number. You're not going to pick every 82.2th thing. So what we do is we figure this out, and then we round down. So take 82.2, round it down to 82, and boom, K is 82 here. Now, what does this tell you? Well, K being 82 tells you that I'm going to pick every 82nd thing. So, for instance, if I started at 1, my first one would be picked. My 83rd one would be picked. I go 82 more. And then 83 plus 82, my 165th item would be picked. So on and so forth. But you don't always want to start at 1. You don't want to start at the first item of the day. You want to start at a random spot. That's what we did here. We said, okay, pick a random starting point between 1 and 82. Let's say you start at 9. Well, who will be the first 4 individuals in the survey? Well, luckily you're given it. 9 will be the first one. And don't worry about this formula right here. It's just a fancy way of saying add 82 over and over again. So what we're going to do is take 9 plus 82. Boom, 91. Okay, number 91 is your next. Take 91, add 82 again. 173. Take 173, add 82 again. You end up at 255. And since it asked for the first 4, bam, there you go. By the way, you could keep doing this 40 more times to get your whole sample. But since it asked for the first 4, there you have it. The hardest part is getting K, realizing that's how many items you'll skip, I guess. So every 82nd item in this case is what you'll pick. Get your random starting point, in this case 9, and then just keep adding 82 to 9. That generates your sample. The last form of sampling we'll be talking about in this chapter will be cluster sampling. So, this one can be confused with stratified sampling, so I want to make sure to emphasize what stratified sampling is first. In stratified sampling, I take the overall population and I break them down into groups that are similar. So, for instance, I took the overall U.S. voting population and I broke them down into Republicans, Democrats, Independents. I could, as another one that's pretty common, take the population, break it down by race. White, black, Hispanic, Asian, so on and so forth. And if I wanted to, I could take the population and break it down by, say, sex. Male, female. That is stratified sampling, where I take the population and break it down by some homogeneous trait where each group shares something in common. This is different than cluster sampling. A cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. So, what you are going to do with the cluster sample, you're going to start with the population, and with nothing in mind at all, just chunk that population. You can capture Republicans, Democrats, and Independents all in one chunk. Maybe it's by like zip codes, for instance, kind of randomly. But what you're doing is you're chunking the population with nothing in mind. Just, you guys get over here, you guys get over here, y'all get over there, so on and so forth. Now, by me not knowing what each group has in common or does not have in common, ideally what I'm doing is I'm just kind of getting little representations of the population within each cluster. By me just randomly doing zip codes, let's say, ideally each zip code is a pretty good representation of the overall population. So notice the difference there. Stratified, I'm intentionally creating these groups with some characteristics in mind. Cluster, meh, y'all get over there, y'all get over there, y'all get over there. Hopefully everybody is diverse enough in each group. That's cluster sampling. For instance, treating each classroom of students as a cluster would be a good way to break down, say, the university population. Hopefully within each class you get a pretty good representation of ages, genders, majors, so on and so forth. Another example would be picking random Ford dealerships for a Ford dealership survey. Hopefully you get kind of a good mix of sales within each dealership that's representative, say, of the overall population. To further break down the difference, I did give you guys this chart. Feel free to refer to it, but notice that with stratified sampling, you have homogeneity within the group, meaning each group has something in common, versus with cluster sampling, ideally you have homogeneity between groups, meaning this group over here is hopefully pretty similar to that group over there. Heterogeneity, meaning differences, in stratified sampling occurs between groups. Republicans, Democrats, different. Whereas cluster sampling, you want the differences to kind of show up within each group. Ideally, this group over here has a lot of the same differences within it. Maybe something like white, black, Hispanic, Asian, something like that if we're going with race. As this group does over here. Hopefully they have a good mix as well. So cluster sampling, heterogeneity, meaning differences, will occur within the group, which is perfect. Now, why would I pick one or the other? Well, stratified sampling, me being very intentional, allows an increase in precision and representation because I know I'm getting that split that I'm after. Versus cluster sampling is very good at reducing cost and improving efficiency because each group will be a little mini population, for instance. By the way, once I chunk up the clusters in the population, hey, y'all go here, y'all go here, y'all go here, what I'll do to do my sample is I will just randomly pick one of the groups or more of the groups. As a visual, here is a simple random sample where I start with a population and boom, 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 randomly pick people. Systematic sampling is me going skipping 2 people, for instance. So I started randomly here, skip 2, skip 2, skip 2, skip 2. Stratified sampling, first off, I break up all these people into light greens versus dark blues, and then I pick randomly within each group. Cluster sampling, I first chunk up this overall population, and then I pick random chunks. Here's some advantages and disadvantages of different sampling styles, just so you guys can go ahead and gather when or where you might want to implement the different styles. Largely, though, those are going to be what we're after. So feel free to pause here and kind of note the nice differences here. Last but not least, I do want to talk about different types of sampling that you may encounter that might not be the best. First one that you may encounter that might not be the best is convenient sampling. This is going to occur when one obtains a sample in which the individuals are just easily obtained or, really not picked on randomness. For instance, if you do a Facebook poll and you just let all your friends do it, it's all your close by relatives, well, that probably won't say much about the overall population. You're probably friends with a lot of people that have roughly similar views. I know we all have, say, crazy aunts and uncles and, say, crazy friends, but you know what I mean. Mostly it will be relatively similar to at least where you grew up. Convenience sampling is not valid due to lack of randomness. we need sufficient randomness, which all those other forms guarantee. Other types would be self-selected samples, otherwise known as voluntary response samples. This is actually a prime example of convenience sampling. So, as for instance, if I put out a poll that said, hey, how many of you are wanting to run a 5K in January? Well, if you were running a 5K, you're a lot more likely to smash that yes button than you may be if you're not running a 5K and you're kind of a little more, say, self-conscious about the fact that you're not. You might not want to participate in that poll. So, for instance, who do you think would vote in a survey regarding the Chicago Cubs? Okay, who was your favorite first baseman in Cubs history? Anthony Rizzo or Derek Lee? Well, if you're a Rangers fan, you're going to say, what the heck are you talking about? I don't care about that poll. So if you're a Cubs fan, you're like, oh yeah, I'm in this. I got this. Bam. In that case, it self-selects towards Cubs fans doing it. Maybe another example. Say your favorite news anchor on Fox News or MSNBC were to put out a poll and they use their results, a poll in Twitter, I should say, and they use the poll results to get the information. Do you think that's self-selected at all? It probably is. Probably people following that individual on Twitter would be fans of that individual, so you get a lot more people that are likely to agree with that individual. That would be a self-selected sample, which is the ultimate form of convenience sampling. One last thing to do. It turns out, disregarding the convenience sampling, if you want to combine those methods that we mentioned earlier, like stratified, systematic, or cluster, turns out you can combine those methods, not a problem at all. In fact, Nielsen, who does all of your TV ratings, if you hear about TV ratings at all, it's through Nielsen. Nielsen will first divide the country into geographic areas, such as city blocks or graphical regions. Sounds a lot like cluster. Or I guess that could be like a little bit stratified if you're talking states and everything as well. And those ones are kind of a little bit harder to negotiate. Let's go ahead and call that one stratified, because you are splitting up geographic regions. They all have something in common. So stratified all day. Apologies. Well, once they do that, then they send representatives to the areas to list the houses from which a simple random sample is used. So once you get your strata, you go send representatives, and within each strata, hey, there's your simple random sample. Bam. Hey, Nielsen just combined two different methods. So that is how we're going to be keeping things random, as well as how you can maybe guarantee a little bit more information, like good representation in stratified sampling, and maybe cheap cost in cluster sampling, and lack of complexity in systematic sampling. If you have any questions in the meantime, please let me know. Please refer back to these charts. I really do think they are helpful in determining the difference. But yeah, let me know if you have any questions, and best of luck to you. Thanks. Bye.